Welcome to QuEra's Quantum Capsule. In this video, we'll explore Bell states. A Bell state consists of a pair of maximally entangled qubits. Measuring one qubit of a Bell pair instantly reveals the state of the other qubit, regardless of their distance. Bell pairs can be set up to be correlated, in which case they both measure 0 or both measure 1, or anti-correlated, in which case one measures 0 and the other measures 1. To create a Bell state, we start with two qubits in their ground energy states. We use a Hadamard gate to place one qubit into an equal superposition, a state with an equal probability of measuring 0 or 1. We then use a CNOT gate, with the qubit in superposition as the control qubit, to entangle the two qubits, creating a correlated pair. To create an anti-correlated pair, we can apply an X gate to the second qubit or start from the one state. A Bell state starts the entanglement swapping protocol, which establishes entanglement over quantum networks. It is also the start of the quantum teleportation protocol, which is used in quantum key distribution over these quantum networks to establish secure communication. Distributed quantum computing can be established the same way, enabling multiple quantum computers to share in the processing of large problems. Unfortunately, creating Bell states isn't a perfect process. Besides environmental noise, the implementation of the Hadamard and CNOT gates can introduce errors. In fact, a Bell state can be used to quickly assess the quality of a quantum computer, as it is easy to visualize the differences between the ideal result and the actual one. In summary, a Bell state is a maximally entangled pair of correlated or anti-correlated qubits. Despite its relative simplicity, it has significant real-world applications in cryptography and computation. Creating Bell states is currently error-prone. Bell states can be used to measure the quality of a quantum computer. Thank you for watching QuEra's Quantum Capsule on Bell states. We invite you to explore our other capsule videos for more insights into quantum technology. Also, visit QuEra.com to learn more about our neutral atom quantum computers.